Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On today's episode, we're going to hear from Sarah Krasnik. Sarah is a lead data engineer at PerPay, a buy now, pay later startup. Sarah writes and speaks a lot about bringing engineering best practices into the data workflow. And in this episode, we hear a bit about how Sarah thinks more about infrastructure as code, dev staging, and prod environments, and what it means to be self-serve analytics. The episode goes into the nuts and bolts of the data work and is a great listen for practitioners.
Sarah and I originally connected on Twitter because we both had recently given talks about the power of Terraform in a data context. Sarah is the only person I think that might actually Terraform her grocery list and everything else about her life that she could figure out a Terraform adapter for. It's been fantastic to learn from her.
Yeah, and she goes really deep in a lot of the cutting edge for how do you think about automating things in the data stack. So it's a great episode to learn more about how to bring it to your stack. So without further ado, let's get into it.
Sarah, thanks so much for being with us.
It's my pleasure to be here.
So I see you went to Hopkins, and you may or may not know this, but I grew up in Baltimore. So here's my question to you. Tell me you lived in Baltimore without telling me you lived in Baltimore.
That is a really great question. And I would say that I will tell you that I went to college in Baltimore and did not live in Baltimore outside of college, but by saying that I didn't actually go very far north, further north than Charles Village.
Yeah. Charles Village is it's a microcosm of, does anybody live there that doesn't go to Hopkins?
Not really. I would be genuinely surprised if that was the case. I would imagine it's one of the most expensive parts of Baltimore. So the question really would be why.
Aren't you supposed to say what is Old Bay spice? Isn't that
right.
a Baltimore thing?
It's supposed to be about crabs or Old Bay or something. Yeah, but Charles Village is also a good answer. So your undergrad degree is math and cognitive science. Is that right?
Yeah, that's correct. So the cognitive science major at Hopkins is you could really take it in 5 different directions. There's literally 5 different focal areas. And one of them is neuroscience and more of the kind of pre-med routes. There's kind of those folks as well. But there was a computational side of it, which if you think about it, it's linguistics plus computational cognitive science. That's really the fundamentals of NLP. And if you were to do a PhD in natural language processing, that would be kind of the route that you went. So I kind of focused on that area. And so that's where the computer science came in. That's where the data science aspects came in without calling it data science.
Got it. That makes sense. I was trying to connect the dots between that experience and then one day you just have a data engineering internship. But it does seem like there's a transition there.
Yeah, so a lot of classes would be in R and Python, basically. And so I think the cognitive science umbrella was really to appeal to the pre-med folks, but also appeal to kind of everyone else that wasn't going to become a doctor.
Cool. Over the past, 6 months or so, I've been following you on Twitter. You now have a Substack, which we will definitely plug. We're raising the stakes on you continuing to write on a regular cadence because now there's going to be a bunch of people ready to read it. But your initial Substack post I thought was so neat. It was a thing that I deeply believe that I can't seem to get people as invested as I am in. It's that people who care about data and people who care about data at the business/strategy level should also care about the underlying storage systems because their experience of data actually directly flows from those storage systems. And I think that too many people are unwilling to think about database-y type things like the CAP theorem and all these different. I wonder, one, did you get any feedback on that post? And two, how did you arrive at this point? My sense is that you were writing from some place of, I've tried to convince a lot of people of this and let me get it all out there.
Yeah, where it really came from, honestly, is I spent a large portion of 2021 transitioning PerPay's data storage from purely a data warehouse to a data lake so that we could try to leverage it in a variety of different ways. And I spent a lot of time thinking about why am I spending so much time doing this? And it was really convincing people that you can't have real-time applications on top of a data warehouse without thinking about it further. And it was really trying to explain, well, if your data's all in one place, why can't you do that? And the answer is, well, are websites built on data warehouses? No, there's a reason. There's a reason for that. If there wasn't, we would be in a very different place. So that was really where it came from. And I kind of relate it to, if you think about front end development, if you think about React, a lot of people don't know what React is, but front end developers will, and they will swear by it. And it's because it makes their lives a lot easier and they spend a lot of time thinking about it. So I kind of relate those two things in the same way.
Okay. I want to go like 800 levels deeper on that.
Yeah.
That was just like such a good nugget of information, just because we've spoken about the data warehouse, data lake divide, and there's like, lots of jokes we can make there. But people talk about the power of a data lake, but I actually haven't gotten to speak to anyone who's gone through the migration process of like, hey, my data warehouse fell short for these reasons. And I actually needed to combine batch process with real time, and maybe there are all these other websites that need to pull from this information. And so I'm going to do the really, really hard work of moving off of my data warehouse and completely having a different architecture for the storage layer. Just say like so much more about that. Did you need other stakeholders involved to get to that point? Did you need engineering? Like that must have been a lot of work. Tell us so much more about that process.
Yeah, it definitely was a lot of work. Definitely pulled on a lot of people at different areas of the process. I mean, this is throughout this whole thing is where I became very emphatic about Terraform because I was trying to build this entire architecture, but I knew that I would have to do it in a staging environment and in a production environment. So I didn't want to kind of go into the weeds with like AWS IAM roles and security groups twice. I just wanted to do it once and have it figured out. So definitely worked with engineering a lot to be able to actually do the migration. But at a high level, thinking about data warehouses and data lakes, I think part of having a data lake is also actually having a warehouse. Just because we kind of have transitioned to this doesn't mean that we don't use a warehouse. We do. I mean, we use Redshift right now, but the point is that we have data in S3, which is, for those who don't know, basically the object storage. It's like a file system within AWS, but it's very, very cheap to store files and to store data, to really store whatever you want in there. And so having S3 where we can have multiple things we can dump data into S3 once and then have multiple things pulling from that same information. I almost relate it to kind of, you think about the metrics layer, you have this kind of intermediate layer where you're kind of exposing things in one way and in the same way, and then having multiple other resources pull from that layer. And so to me, S3 kind of serves as that place where then we have a data warehouse that is backed by S3. Some of the data we might transform and duplicate and make it hot, right, to expose to analysts in SQL and stuff like that, but also be able to query the data in S3 directly. And also, right, in a third way, access S3 without the warehouse at all. And that's really where the processing that isn't batch, that isn't kind of the traditional SQL processing that we think about, that's where that comes in. And I would say that is what hopefully will kind of open us up to be able to do more real-time applications.
Okay, you've said like a dozen things that I'm so interested in.
Wait, before you, because Julie and I are going to fight this whole episode to figure out who's going to get to ask the next question. What do you see as the buckets? As you're talking, I'm trying to figure out, for the world of application development, what are the different types of data stores? And then I want to like figure out if there are similar or, identifiable buckets on the data side. It seems like, you've got your Postgres bucket, which is just like your kind of main transactional database. And then you've probably got your key value store bucket. Maybe you've got a cache layer. But how do you create these buckets? Yeah,
I'm actually even going to take one sliver of that and just go into the bucket that kind of powers some of the data warehouse. And the way that we've kind of organized it is, I think very intuitive. I would hope that people would agree, but where it's just one bucket powering the back end of the warehouse being, also the data lake. I'm kind of using them interchangeably here a little bit, but within that bucket, one folder is one schema. And then within each of those folders, there's another subfolder that's a table. And then within each one of those folders is how the table is partitioned, right? So if you have some sort of event data, it might be partitioned by date. So that if you query only the last 30 days, it's going to be a lot faster than if you just query an entire, right, maybe 5 years of history.
That would be S3 buckets. So if you think about use case buckets, types of use cases, you mentioned batch, you mentioned streaming. Are these the two primary different use cases that would push you towards a more data lakey environment, or do you see other main use cases too?
Those are 2 use cases. I would say there is a third use case, which is kind of the data science use case of putting like pickled, files for training data sets or test data sets. But I would say that from a data engineering perspective, I think that's a little bit separate from the data warehouse versus data lake conversation. I think that can be used in tandem with either approach.
Yeah, I think the way the world is going to look in the future is it's not going to be like data lake or data warehouse, but you're going to compete for which workloads you want to put on the right system depending on what you want to accomplish. And so it's like the practitioners that get to pick, hey, I have this problem I need to solve, and it's better served with this infrastructure layer, and being able to be really flexible. Like the thing that you mentioned was the metrics layer. You also mentioned using Terraform, where you have these levels of abstraction such that, hey, I need to do this thing, and I put guardrails up so that when I want to do this thing, it's going to work as I expect. It's just like the power or the engine is going to come from the appropriate engine, whether it's the lake house or a warehouse behind the scenes, which I think is pretty advanced for how I've seen companies think about this setup. But I do think the world's going to move much closer to that of like, these are the tasks I need to do, these are the guardrails, and this is how I've set it up so that depending on what I need to do, like I'll just use the data that's sitting in my lake house or my warehouse.
Exactly. And I think about it in 2 different ways. The first is the kind of entire analytics ecosystem and all the people in it, I think will agree that you don't want to, we want to make things more repeatable and also not duplicate data, right? That's why we have, that's why we're moving towards a metric store. That's why that's why people are using dbt, right? And so I think that from a data storage perspective, it's the same thing. You don't want to just copy data, the exact same piece of information into multiple places, because then you're duplicating it. There's more opportunity, right, for things to go wrong. There's more room for error when you're duplicating it that way. And the second thing that I kind of think about is what is the right tool for the job. One thing that I kind of go around saying a lot is like square peg round hole. To me, streaming applications and data warehouse, it in a lot of situations, it can be a square peg round hole. And so what I'm trying to figure out is, and what I think about a lot is, how do you, right, there are use cases for both of them. They need to coexist. And so how do we have those 2 things coexist without creating a lot of duplication?
So when you started the conversation about like how you made this shift, you mentioned something like, you just had a brief second, you're like, oh, the first thing we had to think about was environments. But there's like a whole separate conversation, I think, to be had around like, how do you do that well? And as the product person responsible for environments in dbt Cloud, I certainly think about it. But it's almost these words that have like special meaning applied to them, development, staging, production, but there aren't really, people do it quite differently depending on their organization or how their team works. What happens in each of those environments in your setup?
Yeah, I think environments are kind of a very important concept that I think started on engineering teams, but really a concept that I think is relevant to engineering, analytics, honestly, even like business and operational teams. So I'll start with kind of development and how I like to think of it, how engineering teams think about it is kind of local development, where you could be disconnected from the internet in theory and still, right, like make some sort of application or do something locally. But here, right, the analogy of developer is analytics engineer, data engineer, just analytics person who's writing code or just doing something. And you're creating a GitHub branch, maybe scripting some stuff, architecting, running pieces of something to make a change. And really, I think the fundamental characteristic of a development environment is that it's localized and separate from any other environment as much as possible. And to make this tangible, I think it's kind of helpful to walk through a specific example. So let's start with simply updating a SQL query. So in development, this could be running this query to completion in maybe your own schema in your data warehouse and validating the results, looking at what they are, what you expect them to be, maybe running some statistics on the results just to make sure that your query is doing the thing that you want it to do. This is testing, which I'm sure we'll talk about later in the episode as well. But moving to staging, the movement from development to staging is when you think you're ready for production. And what you're trying to do in staging, from my perspective, is verify that, okay, this is actually production ready. So the purpose here is to run some process end to end with your change as a sliver of that process. So let's say the query being modified is used downstream in some other task or some other job. So obviously you test your query end to end and you know what you expect, but that likely doesn't live in a vacuum. Even if some other query isn't using it, maybe you're writing it because you're trying to update some sort of dashboard or write something else. There needs to be a place to make sure that integrations work, that kind of the edge pieces of your change all fit together. Your output could be what you expect it to be, but changing something as simple as one column from a Boolean that's true false to a 0 to 1 integer because you want to sum over it in a dashboard, that's expected for you, but it could be unexpected for some sort of other downstream process or for someone else. So this environment is really trying to be production-like without the impacts of production. And so to kind of jump to that, what really is the impact of production? To me, it's the dependencies on production actually influence decisions and influence end users and customers. So production data either powers dashboards or reports or reverse ETL processes into operational tools, but basically the level of exposure in production is at its highest. At this point, the production data is data that's extremely visible by other people outside of your team and sometimes even outside of your organization. You don't want to test here because, again, the exposure is highest. And so you want to make sure to, before any changes are put into production, to make sure that everything is going to work as you expect it to.
So playing that back, development is like you have your own playground. You're doing your work. It's isolated. You can't mess up things too bad, but you're just validating that your code's going to do the logical thing you want it to do. In staging, the bar's even higher. You're figuring out, is it going to work end to end with all the other complex logical queries that happen in my warehouse? And that's where all your testing, all the kinks are really ironed out. And then when you get to production, there's no room for error because that's what all of your downstream systems are consuming, and production has it's been battle tested already in staging.
Yeah, exactly. And I think that's putting into production, that's where the concepts of CI/CD and versioning come in, right? I mean, no one's perfect. We all make mistakes. And so we want to make sure that, let's say we tested in staging, but missed some sort of error, just missed something. If we roll into production and there is an issue, we want to be able to know what the previous version is, roll back to it, and know that we're okay. And we kind of can buy ourselves time to actually fix the issue and kind of retest.
Yeah. So staging that's where I think the real muscle comes in. Yes, like you actually have to write interesting, do the data work first. But staging is the hard part in my mind, where there are a lot of edge cases that you have to make sure that are handled. What does that look like? For us, we're on Snowflake, so we have 0 copy clones. We'll actually run all of our tests. We write lots of tests on all of our models. We actually will do a comparison often with our consumption layer, make sure things are looking as we expect. We have automated tests, but there's just like a whole variety of suite of things that can be done in staging. What does that really look like for your team?
Yeah, I think the first thing that I would like to point out is when talking about testing, this is, I think, where the concept of staging is most different for analytics teams and data teams than it is for engineers. Because for engineers, you can test some user flow. It doesn't matter how many users exist, right? You just want to make sure that your UI is looking how you expect it to. But in a data world, when you write tests and you expect an average of some sort of column to be between some sort of range, that actually, if that's the case in production, you want that to be the case in staging. Otherwise, if you have a difference in that data, your tests are just going to be off. And so I am a big proponent of setting up a staging environment that actually has production data reading into it, and then you make adjustments on that. So what kind of data quality might look like? Well, actually, I'm going to answer that question a little bit backwards in terms of what data quality doesn't look like. It doesn't look like missing tests and only half tests in staging, because then that's going to result in broken dashboards. It's going to result in broken pipelines. And that's where the exposure and production happens. So how to test in staging, our entire test suite. We use Great Expectations at Perpay. I think there are a lot of other tools. There's SOTA, there's obviously DBT tests and all of the integrations there. But as much parity between staging and production as possible. So first you have your SQL tests, but then also you have as many integration points as possible. So for example, if we populate Facebook audiences for marketing, that needs to be tested. That's right. It's outside of the analytics ecosystem, but the exposure is, I would argue, highest because it is outside of the analytics ecosystem. So what we've done is actually set up like test audiences in Facebook that don't power anything. They don't power ads. There's no money being spent, but we can send data to them to make sure two things. The first is that the integration actually works. And the second is to make sure that the numbers actually match the ballpark of what we expect. So if we expect some audience size to be, right, 5,000 or 10,000 people or whatever, that we can validate those types of things.
Got it. And so your kind of data system is powering something as important as like your Facebook ads. So that can be more on a real-time decisions that happen is when the data gets promoted into production and you feel pretty confident in the models that you've built. Is that like an automatic end-to-end? You've made some decisions on creating Facebook audiences and then you do spend real money for ads against those models?
In a production system, yes. So that would be kind of where the marketing strategy comes in. But as far as kind of the analytics and data engineering side of things, it's really just implementing what the strategy is and making sure that those audiences are up to date.
Okay, so everyone puts testing often not as high as they should because it ultimately, everyone knows they should do it, but they sometimes don't get around to it. What is that number one thing on your backlog on the testing front? We were like, if I just had a week to myself, what would you implement?
Well, first of all, if I only just had a week to myself, that would be quite excellent. To basically be able to just like implement whatever I wanted and stop time for a little bit. But I would say that on the testing front, I really think that the biggest issues are when data leaves analytics, when it leaves the analytics ecosystem, and figuring out how to test those integration points. I think that's such a huge struggle, and figuring that out. I don't know what the answer is, but spending time actually thinking about it, I really think that I could come up with something that might be half decent.
I completely agree that the integration points are always the hardest thing to test for. I mean, when it's the data's leaving, that's totally true, but also when it's coming in. I think that anytime you have a single compute infrastructure where you can like look at thing A and thing B and compare the two of them, like it's fairly straightforward. You just have to figure out how to express the logic. But it is such a challenging question of like, how do I make sure that all of my Salesforce data actually made it to my warehouse or lake? I think most of us actually just trust whatever tooling that we use that like, well, somebody would have filed a bug if the Salesforce connector was broken. But the boundaries between systems are, I think, the most brittle points of the entire ecosystem today.
Yeah. And I mean, if you think about like engineering teams, right, they have a whole API contractual layers between backend and front end systems. And this is right. Integration testing is like such a huge deal. But with analytics, to me, I think that is really the testing aspect that's most important in terms of what do those contracts look like to basically make you sure that what you're looking at is really representative of the real world.
I want to switch gears a little bit because you also mentioned a topic around infrastructure as code and that you use Terraform in making sure declaratively that your systems are going to run as expected. I think this is such like there's endless opportunities here to define more things in code, but what are some really tangible examples of how you're using Terraform in your data stack today?
Our analytics team has really taken the same road as our engineering team, which is defining honestly as much analytics infrastructure in Terraform as code as possible, aside from kind of the SaaS tools that we use, honestly. So for instance, we host Airflow internally. And so we self-host, and all of that infrastructure is defined in Terraform. So the EC2 box within AWS, all the, exposing that to the VPN, all of those kind of connectors, that's all defined as code. And similarly, we copy data from a variety of production databases to either the data lake or the data warehouse. And because we're in AWS, we use kind of their solution, which is DMS, standing for data migration service. And really it just like copies data from one place to another. All of that configuration in terms of, right, what database can talk to DMS, what warehouse can talk to DMS, and making sure that all of that is configured and also monitoring around that. And that is all done in Terraform. And first and foremost, I mean, the benefits really would be allowing us to manage access and security. I mean, that's a huge pain. I would say definitely in AWS, but GCP as well. And as an engineering organization, I mean, we've shifted from hosting infrastructure publicly to hosting it in a private network. And so what that means is that we have to think even more about security in terms of, instead of just saying any traffic from this IP is okay, we have to establish some sort of SSH or some sort of other connection. And that can be difficult in itself. And so being able to establish one way of doing that and then just copying it and be able to kind of plug and play in that way, Terraform has really stepped in to be able for us to be able to do that.
I obviously am such a big Terraform fan. The UX of Terraform is the inspiration for DBT in the first place. One of the things that feels hard to me is to draw the boundaries. What things is Terraform responsible for and what things is DBT responsible for? They're in a world where you're talking about Snowflake. There's a Terraform provider for Snowflake. And so you can go like reasonably deep into the Snowflake set of objects and specify them all in Terraform. I think that there is probably a point beyond which it starts to not actually feel like the right place for it. Do you have a theory on like where to draw this line? And this is not a trick question. We don't feel like we have a perfect answer to this today.
Yeah. And I mean, to be fair, I don't think a perfect answer exists. So, if anyone does say that they have the perfect answer, I'd love to hear it. But my take on the question is, I mean, the two things that I kind of think about are, first, how many times is it going to be repeated? If I'm doing the same thing and it takes more than 15 minutes and I'm doing it once a week, to me, I want to code that just so I can save 15 minutes of my time every week and maybe cut that down to 1 or 2 minutes. And then the second thing to think about is how often are things and how often are things changing? So if something is changing extremely frequently, I mean, maybe once a day, maybe multiple times a day, and it doesn't take very long, coding that and then putting up a PR, having someone else review it, right? It could be, the change could be so not non-consequential that it just doesn't make sense to code. And so to me, it's like, what is the time it takes to actually make the change? Where is that the smallest?
So I'm going to read you a quote of something you've written, which is, my goal as a data professional is to automate myself away, which is kind of a confident thing to say, right? Like, this is your job, but we call it internally like moving up the stack. How do you make those like tedious things automated? Any other big productivity hacks that you've figured out for your team?
Yeah, I actually think that this question, I mean, it's like very much related to what do you put in Terraform and what do you not, right? So if my whole job is managing access to our warehouse and I spend an incredible amount of time like creating users and all of that, but I could reduce the time there, I mean, why would I want to continue doing that if it could be more efficient and my time can be used elsewhere? I definitely do stand by that. And if I remember correctly, I wrote this after I read a thread about, data engineers being wary of SaaS tools, and what the job market is going to look like. And my first thought was, if Fivetran does what I, used to do 3, 4, however many years ago, it's an incredibly successful company. And why would I want to spend all my time maintaining API integrations? That sounds extremely repetitive. I personally bring no unique value to that. And so why wouldn't I want to focus on something that I can kind of bring value to. And as far as kind of where the wins come in, I would actually say the biggest wins come in pretty early. Perpay is, I think, extremely data literate, and the biggest wins have been pushing for adoption of some of the tools that I mentioned, like Fivetran, like Census, to kind of reduce time to onboard new integrations. But I do think that it's important to call out that the analytics ecosystem and within there, it's very easy to look at people and companies who have already adopted a lot of these tools, but there are many organizations that are way further behind, especially in fields with much larger institutional history, like say manufacturing or finance. When I worked in an analytics organization, a large manufacturing company, that was kind of my first job out of undergrad. Leadership was very wary of open source. And that was something that we had to think about. They're very wary of open source, very wary of cloud. And so a lot of things were done in-house, and it was not that long ago. And subsequently, when I worked at One Main Financial, which is a lending firm based in Wilmington, Delaware, a while back. So some teams, use Looker. My team was one of them. And that was the affiliate marketing team, where think about how, you look at credit cards or loans on sites like Credit Karma versus NerdWallet. My team was kind of responsible for assessing which affiliates were performing well and which affiliates weren't, and how do we want to kind of maximize efficiency of profit kind of in those channels. And part of my team would spend time forecasting for loans coming from affiliates in terms of how many loans coming from each affiliate, how much would it cost us, so on and so forth. And believe it or not, the forecast was not only built in Excel, but the comparison between the forecast and the actuals was also done in Excel. And that was reported on weekly. But because the forecast was complex, because it reflected some complex interactions with macroeconomic systems and all of that, it took almost a week to update. So, doing the math, most of the time was spent updating the actuals for the forecast to be able to report to maybe a leadership team how we're doing. So one of my projects was to help this kind of part of my team to move this forecast into an automated job that would report on actuals versus the forecast in Looker as opposed to Excel. And what this kind of enabled some of my coworkers to do was, where they had a unique understanding of the economy, just other things going on that are much harder to code, how the market was doing. I mean, this was pre-COVID, so stimulus and vacation spending, all of those things weren't fluctuating as much, but those types of things are much harder to automate, harder to incorporate into a forecast. And so that's kind of where I think the biggest wins are early, and honestly at organizations that are catching up and really still trying to onboard with these tools that have made our lives kind of a lot easier.
Yeah, I think part of the conversation that we don't talk about enough is a lot of these challenges can be organizational, and we can talk about best practices all day long, but there's a lot of good reason why some organizations decide to buy versus build, or why there's resistance to bringing in some new technology or new process, because organizations and people are super complex. And I think that's a whole nother topic we could go into. It's how do you have those skunkworks projects, or how do you bring change to an organization if you do think that there's a better path forward? But often we have the privilege of, when people come and talk to us about DBT, they're already kind of bought in on that mindset, but there's a whole nother kind of beast of problems of how do you get people over to that mindset of change can be good, or you can outsource some problems.
Absolutely. And I think also, again, going back to the larger institutional companies with a larger history, but also in areas where there might be more compliance things, there's a lot to think about. Onboarding a tool isn't just about, does it do what I want it to do well? It's also about to make sure that you won't be sued if you start using the tool. But that's genuinely important in a lot of industries. And so thinking through that usually means talking to compliance experts and lawyers and getting a lot of people involved that aren't data people. And so that can certainly be a slow process as well.
Yeah, things can snowball and get complex quickly. I'd love to get your take on another part of data that you've written about, which is like self-serve analytics. You talk about automating away the tedious stuff about the data practitioner's jobs. You have a lot more time to focus on the high leverage parts of your job that really move the needle for the business. But people are always trying to build towards this like aspirational self-serve analytics organization where everyone can answer their own questions about data.
After you ask your question, I want to read a tweet because I was literally Sarah, I'm on your feed. I'm like stalking your feed, and there's like such a perfect tweet to
go for it.
Okay, so this is at Seldo from January 11th. If the engineering team went to the marketing team and said, "Okay, we've set everything up to be self-serve. If you want to launch a new microsite, you just have to deploy a new Gatsby instance," they would get laughed out of the room. Essentially, posing the question like, why is this the mental model that everybody seems to adopt as obviously correct one in data? And I think that sometimes it's very useful to like take the most ridiculous possible stance because it helps you see something in a new light. But it is a good point. Like, why does it seem so clear to so many people that this is a good idea?
Yeah, that's a really great question, Tristan, because I also don't know why so many people think this is a good idea. And I was going to go on, honestly, I'm a huge fan of analogies, maybe to a fault. So I'm going to go that route. Maybe let's talk through frozen yogurt. So if I go into a froyo shop and they advertise self-serve, I get really excited about that because that means that I can make my own froyo bowl.
Yeah, you put all the gummy bears in.
Exactly. Gummy bears, M&Ms, you just put it all in there. And people like it because it's self-serve. But really, if we take a deeper dive into this, I walk into the froyo shop. All of the flavors have levers. They're all labeled. I know exactly what I'm going to expect. I know exactly what I can expect. I can taste test. All the toppings are organized. They're also labeled. And then I just put it on the weigh scale and pay. When people say self-serve froyo, they usually do not mean going to a farm, milking the cow, making the froyo, and then putting it into the shop. They just want to make the bowl themselves, and that makes them feel very, accomplished and good. And I am one of those people as well. But similarly, right, I think self-serve, right, it's one of those terms that I don't think it's black and white. I think it's very much a gray scale. Fully self-serve from raw data is just open to misinterpretation, getting different numbers, right? I mean, I've said this, I think, multiple times. I will continue saying it. I've been in a room when two teams are arguing about, right, whose actual numbers for some forecast are correct. And really one team defined their week starting on a Sunday and another team defined their week starting on a Monday. When you look at raw data, right, there's a high amount of context that's needed to look at it. But I'd also argue that, right, we don't, we want organizations to be data literate and understand, what the data could mean and what it can allow them to do. So I'd argue that self-service starts when you get to a point where the context is easily documented. And this means organizing data, cleaning it, understanding how much of it is missing. Is that okay? Is it not okay? Testing it and building out the second layer. And I mean, I think this really translates to even potentially, right, where the metrics layer comes in of before that, if we have all this raw event data that can be, right, knowing, well, is the event data going to fire or is this event data coming from some user who has an ad blocker on, right? That's like not necessarily a common known thing. And so documentation and access is important, but really what it is like building context. So people can take the data, know what to expect, and answer certain questions. And that's really where I think data literacy comes in, of understanding what questions are worth asking, and then how can you use, clean and transformed and aggregated data, but how can you use data to answer those questions?
You mentioned Looker in an earlier job. I think that there's reasons to not love LookML because it's generally pretty tied to the Looker platform, et cetera, et cetera. But I think that the reason that Looker has become so pervasive is that they got the line absolutely correct between what should be self-serve and what should be done by the data team. And it was defined at that boundary between the LookML editor and the Explorer interface. And again, okay, maybe you could want advances in the Explorer interface or whatever, but like that line is so important. And I feel like it's exactly what you just said. It's like maybe for some personas, it is like your fact and dimension models. But I think the best possible one for the broadest audience is the business metrics and, actually defining how they act, what they can be sliced by, what they can be filtered by, et cetera. It seems like you've spent some time thinking about the metrics layer, which is exciting to me. I didn't realize that. Is that what you're hopeful that, like the promise that you are hopeful for?
Yeah, I think that's definitely something that I'm hopeful for. But I also think a lot about so the metrics layer is a concept. I mean, I think we've been talking about this for a while, but in reality, what does that actually look like, right? Is it an API endpoint? Well, that obviously limits who can interact with it. Is it just fact and dimension tables? Well, that also limits who can interact with it because it's not an API endpoint. And so I think that it's not only the metrics layer, but also defining what is the optimal format of the data for different users, right? It's about who's using it. And I think that's really important to think about. And I think that if we start trying to generalize that for only one user, I don't think we'll get to a right answer. I think there are going to be kind of multiple different answers and multiple different ways that we want to expose the data to make it quote unquote self-serve.
And so I think, left it at a good spicy take. Self-serve isn't the promised land. You need to do a lot more of getting your M&Ms and gummies and good labeled boxes and give people handles to make their froyo.
I would be so upset if I went and pulled on the vanilla handle and it was chocolate. I do not like chocolate froyo, so I get the metaphors. Makes so much sense.
Yeah, I think there's probably a different experience for going to milk a cow in a farm and making froyo, but you got to be clear up front with the expectation for what you're signing up for. But we ask this of all our guests. Our final wrap-up question is, looking 10 years out, what do you hope will be true of the data industry?
Yeah, I'm going to try to kind of keep it short and sweet here. Tristan and I have both spoken about this in conferences. We've talked about Terraform here, but I'd really love to see data infrastructure defined in some central way. Could be code, could be not code, but integration points I think are extremely hard to manage. There are a lot of data tools making our lives easier, but we also have to manage their integrations and kind of figure out how they're going to talk to each other. And so I think all of that won't be seamless until they're all defined in one place and we can kind of understand how they all integrate. So really it's about centralizing definitions, even if it's code and not configuration. And to do this, the vision has to be shared across both practitioners and vendors, right? So vendors need to build API endpoints to allow creating and modifying, viewing resources like SyncsDTL and so on and so forth. But I'd love to see some standardization here and more talk on best practices with tools we already use.
Sarah, where can people find your Substack?
My Substack is Sarah's Newsletter, and very original name, I know, but I'm also on Twitter as well. Just search for me as Sarah Krasnik, and that's where you can find me.
Wait, did you actually get Sarah's Newsletter.substack.com?
I did. I looked for Sarah.substack. It was crazy. And all of them didn't have any articles under my name. They were all coming soon.
Huh. Well, thanks for hanging out. It's been a lot of fun.
Thanks, Tristan. Thanks, Julia.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.